for the applications, let's first start with this one. We have the dimensions of a square. It says that a square has an area of 144 square feet. Find the length of a side. All right, so let's draw a picture. Pictures always help when we're doing these application problems like this. So remember that a square is defined that all the sides are of equal length and the four angles are 90-degree angles. So this square has an area of 144 square feet. Find the length of the side. Now the thing that they're asking you to find most often is the thing that you're going to let your variable be. So it's saying find the length of a side. So we're going to let x equal the length of a side. Let's draw that in. There's a side, there's a side, there's a side, there's a side. Go back and read the problem again. A square has an area of 144 square feet. So here, let's see. If they're saying something about area, we should probably use an area formula. So if you would look on the back fly page of your book, you'll see that page is all the formulas for different geometrical shapes. So if you have a question about what formula to use, you can always go back there and check that as a reference. But the area of a square is the length of a side squared. That's the area. Okay? So we're using this formula and we're going to put in what we know. What is the length of the side? It's x, and we have to square that. And what is the area? It says the area is 144 square feet, so we're going to put 144 in for our A. Now we have to solve this, okay? Now it's a quadratic, has a square right there, so that tells you right there, you're going to have to use the zero product property. So remember, the first thing to do is to get a zero. We're going to subtract 144 from both sides. So if I do that, I get a 0 here, and minus 144 there, like so. And now I need to factor this. So 0 equals, looks like a difference of squares to me, an x and an x, a 12 and a 12, and a plus and a minus. Now we have a product, we have a 0, we have a product, so now we're ready to use the zero product rule. It says x plus 12 equals 0, or x minus 12 equals 0. So here, subtract 12 from both sides, we get x equals negative 12, or add 12 to both sides, we get x equals positive 12. Okay, so if we would check these, they would both check and everything would be great, except that this is an application of a real-life object here. And this is supposed to be the length of a side. X is representing the length of a side. So it's okay for the length of a side to be 12, but it doesn't make sense to have a negative length. Okay, so we're going to throw this out, not because it doesn't check, but because it doesn't make sense in the context of this problem. And we'll keep this answer. And we need to make sure and state our answer with the unit. So if the area was square feet, then the length of the side is 12 inches. Oh. Is 12 feet. And that's it for that application. All right, set up an appropriate equation for this scenario. Do not solve, but describe how you would solve it after setting up the equation. All right, this is a picture frame and it's 4 inches wider than it's tall. So let's go ahead and start drawing. Okay, there's our rectangular picture frame. It's 4 inches wider than it is tall. The area of the frame is 24 square inches. What are the dimensions of the frame? Okay, we have two things going on here. We don't have just the length of a side like we had last time, where all the sides are the same. We have different sides. So in that case, we always let x equal the thing that we know the least about. We're going to let x equal, let's see, the picture frame is 4 inches wider than it is tall. We know something about the width. It's 4 inches wider than it is tall. Do we know how tall it is? We don't know anything about how tall it is. So we're going to let x equal, let's say, the height of the frame. Okay, and that means what is the width of the frame? Well, if the height of the frame is x and the picture frame is 4 inches wider than that, then it'd be x plus 4 more inches. It's 4 inches wider than it is tall. Then it says that the area of the frame is 24 square inches. What are the dimensions of the frame? That must mean that we're going to have to use the area formula for rectangles. Can't use the same formula as we did with squares because the sides are not guaranteed to be equal. So we're going to go ahead and find the area of a rectangle is length times width. Again, that's on your back fly page of your book, or you can also look it up in the ebook. So the area we know is 24. Okay, and the length or the height is x, and the width is x plus 4. Okay. And it says do not solve, but describe how you would solve it after setting up the equation. We did set it up. It's perfect. Now, if we're going to solve this, I might multiply this out. I get x times x is x squared. That tells me I'm going to have to use the zero product property. So I'm going to have to get a 0 on one side. I need to multiply this out and get everything put together with like terms, and then factor that entire side. After you've factored that entire side, then you'll set each of those factors equal to 0 and solve those two simpler equations. And of course, you're probably most likely going to get an answer that doesn't make sense here because this is a physical application. So you would throw that nonsensical answer out and keep the one that does make sense. Remember to get your units there as inches. So we'd say the height of the frame is whatever inches, and the width of the frame is whatever inches. The Pythagorean theorem is something that you may have seen before. If you don't remember it, remember you can get it from the back fly page of your text. And the Pythagorean theorem is a theorem that's used with right triangles. That means that it's a triangle with one angle that is 90 degrees. A and B represent the legs of that triangle, the length of the legs, and C is always the hypotenuse. Okay, so those are legs, and this is always the hypotenuse. All right, now we're going to use the Pythagorean theorem to find the value of x in the figure here. Okay, a little different here. I have a squared plus b squared equals c squared. Let's see what we can do. A is the length of one of the legs, so it's x minus 1. But I have to square it. If I want to square that entire x minus 1, I'm going to need to put that in parentheses. Plus b squared, let's call this b, that's an x squared, equals c squared, the c is the hypotenuse, so we'll put x plus 1, and again, if I want to square that entire length, I need to put parentheses there. So we have set it up, now we just need to solve this. So let's go ahead and multiply this out. I have x squared minus 2x plus 1 plus my x squared equals x plus 1 quantity squared is x squared plus 2x plus 1. Okay. If you can't remember how to expand those binomials, then you may want to go back and look at some of the material out of Chapter 5. All those chapters are still accessible to you in the ebook. All right, let's go ahead and proceed from here. I have a quadratic equation. That means I'm going to have to use the zero product property or the zero product rule. So let's go ahead and combine some like terms. I have x squared and x squared is 2x squared minus 2x plus 1. That's all on the left side. The right side doesn't change any. Okay. Now, if I'm using the zero product rule, then I need to get a 0 on one side. I need to get this side to be 0. So I'm going to subtract x squared. Okay. And I'm going to subtract 2x. And I'm going to subtract 1. So I get a 2x squared minus x squared is just a 1x squared. Negative 2x minus 2x is minus 4x. And a 1 minus 1 is gone, just 0. Equals, everything on this side has gone away. So we have the 0. Now we need to get this to be a product, and we get that to be a product by factoring. Remember, greatest common factor. And that is completely factored. So we set each factor equal to 0 and solve. This one is quite simply solved, and this one we need to add 4 to both sides, and we get a 4. Okay, now let's check and see which of these works. Maybe both work, maybe neither one of them work. Would 0 work here? 0 minus 1. That would mean that this length is a negative 1. That doesn't make sense, so I'm just going to throw that out right away. X equals 4. 4 minus 1 is 3. And 4 plus 1 is 5. And x is 4. All the lengths are positive, and we can check this putting it into the Pythagorean theorem. So if this is 4 minus 1 is 3. This is 4. And 4 plus 1 is 5. I can put that into the Pythagorean theorem. 3 squared plus 4 squared equals 5 squared. So that's 9 plus 16 equals 25. And that's true. So the value of x in the figure is 4. Remember, it asks us to find the value of x in the figure. The flight of a baseball. We have the height and feet of a baseball after t seconds given by h equals negative 16t squared plus 88t plus 3. At what values of t is the height of the baseball 75 feet? Okay, so given us this formula for the height of the baseball, so h is negative 16t squared plus 88t plus 3. And what else did they give us? At what values of t is the height of the baseball 75 feet? So they're saying that the height is 75 feet. We can replace our h with 75. So 75 equals negative 16t squared plus 88t plus 3. Now, if I solve this, I bet I can find those values of t when the height of the baseball is 75 feet. So I see that we have a quadratic equation. I know that because it has a square on the variable. It means I'm going to use the zero product rule. Every time you have a quadratic that you have to solve, then it's zero product rule. That means I'm going to get everything on one side equal to 0. So I can get the 0 from the zero product rule. That means I'll add 16t squared, subtract 88t, and subtract 3 on both sides. So on this side I get a 16t squared, a minus 88t t and a plus 72 equals, and everything on this side canceled out, I get a 0. So now I want to solve this. Can I simplify this any at all? And if we can do that, then we definitely want to do that to make the rest of the problem easier. We have a greatest common factor of 8. So I'm going to take 8 out. And what am I left with? I have a 2t squared minus 11t plus 9. And remember, that's all equal to 0. So we'll factor from there. And make your 2 sets of parentheses. And we'll break 2t squared up as 2t and 1t. And let's try a 9 and a 1, and they'll have to both be minus. That gives me a 2t, negative 2t, and a negative 9t makes a negative 11t. So now I have 3 factors that equal 0, and we can still use the 0 product rule. So this factor equals 0, or this factor equals 0, or this factor equals 0. Okay, and 8 equals 0 does not make any sense, so we throw that out. And this one, let's see, 2t equals 9, and t equals 9 halves. Or this one, t equals 1. So it looks like, as far as time, we're doing seconds, looks like after 4.5 seconds, and at 1 second, then the height of the ball has reached 75 feet. Alright, you should be able to do that section of homework then, and be sure and email me if you have any questions.